Okay, I promised you we would get to some really cool features of C Sharp, and we're about to do that right here with defining properties. Properties are a really neat feature of the C Sharp language, and I really like using them. And in this section, we're going to explore what they are and how they work. Properties are essentially like data fields, but they have logic behind them. And from the outside, they look like any other member variable, but they act like a member function. They actually have code behind them. Now, you define them like you would a member variable, but they have a get and a set section of code added. And they can use access modifiers just like member fields and member methods can, and we explored those earlier. Let's take a look at an example of what a property looks like. So let's imagine we had a class called myExample, and we had some private member variable called SomeValue. Now, because this is private, there's no way for someone who's consuming this class to get at that data. Now, we could make it public, which exposes the implementation of the class to the outside world, which is not a very good programming practice. You really want to keep the inner workings of your class private and then choose to selectively expose data. We could also just make a member function, which would allow an external consumer of this class to get the value and set the value. Or we could make what's called a property. A property is defined like this. I'm making a public integer property called current value. And instead of making it look like a member function with parentheses and arguments and so on, all I have to do is define the name of the property with two curly braces, and then inside I put the word get, and the word get here is essentially going to return the value of that private integer that I have. And then to set this value, I have the word set. And in the set code, I'm setting the internal SomeVal property to this word value. And value is implicit. C# just simply generates that for you. Let's see how this actually works when you consume this. So to do this, I would define my X variable, which is an instance of the myExample class, and I'm creating a new myExample object there. If I wanted to get the value, I would just do this. I have an integer I, and I say myEx.currentValue. That will trigger the get logic. And in this case, the get logic is pretty simple. It's just returning the value of that internal private variable. And if I wanted to set it, I would do this, myEx.currentValue equals 5, and that will trigger the set logic. And the value of that special value keyword there in the set logic would be set to an integer whose value is 5. And the C# language in .NET just takes care of all that for you. You don't have to declare some argument called value. It just magically shows up. So you can have automatic properties. Let's suppose, for example, I had my class, which I declared up above in the previous example. So I've got my example class here with my private SomeVal int, and I've got the get and the set. Since all that this example is doing is getting and setting the value of that private internal variable, I could rewrite this very simply just like this. I have my class, and then I have my property, and all I do is have the words get and set. And that's all I need to do. This is called an automatic property. You can also have read-only properties, and you can have write-only properties. Read-only properties and write-only properties are properties that can only be read and can only be written. So let's take a look at an example. Using the same example we've been using up until now, I have my example class with my private variable, and inside my public int current value, I have get and return SomeVal. Now, if I don't define a set, then the property is read-only because there's no way to set it. All I can do is get the property. Alternatively, I can define just a set. If I don't define a get, then the property is write-only. You'll very rarely see write-only properties. Properties are pretty useless if you can't actually get their value. But you can do this. So if you don't define a get or you don't define a set, then the property is either read-only or write-only. All of this is pretty fun, but why would you use properties? A couple of reasons. First, properties can be calculated on the fly. So if you wanted to expose a property that looks like a member variable, but has some logic behind it that actually gets calculated on the fly whenever it gets accessed, read, or set, then you can use a property for that. Properties also provide complete control over the data field access because the logic is hidden from the object's consumer. The consumer of the object's property doesn't need to know how it's calculated or what's being calculated. And if later on down the line, you go back and you change the way this object works, and the way that that property is calculated changes, then the people who are consuming your object don't need to worry about that. They just simply go ahead, keep on referring to that property, but the logic can change. Properties also promote the idea of encapsulation. We've talked about this a couple times before in this course. What you're doing is you're taking the logic that implements that property and you're hiding it from the consumer. So they don't need to worry about how it works. Let's take a look at an example of how you'd have a property whose value is calculated on the fly. Let's imagine I had a class that represented a wine. And in that class, I have a price. I could define the price as just a public member variable like I've done here. And I've got some private ones, like say that there's a wholesale price and there's a retail markup. So when a wine store buys a wine, they don't pay the retail. There's a wholesale price they pay, and then there's a markup that they apply to the wholesale price, which is what the real price is. So rather than having a public member variable, I could expose a public property. And you can see here, I've only defined a get. There is no set here. And when the consumer of this wine object wants to know what the price of the wine is, you can see that the logic inside the getter is simply multiplying the wholesale price times whatever the retail markup is. So I can have some code that goes out and figures out what my retail markup is based on some other parameters I've got in my business. And the consumer of this wine class has no idea how or why I'm doing that. They just simply ask what the retail price is by accessing the property, and it's calculated for them on the fly. Let's jump over to the code and define some properties in one of our classes and see how this works. I'm here in my defining properties example, and I've got my example snippets open right here. And I've scrolled down to the properties section, and I've got a wine class here. So what I'm going to do is go back over to the program code, and I'm going to make a separate class file for my wine class. And this just promotes the idea of encapsulation. And we've already done this once before, but if you skipped over that part or you need a refresher, just follow along. So I'm going to right click on the project name, and I'm going to click add. And then at the bottom of the add menu, I'm going to add a class. And I'm going to call this my wine class. First, I'm going to make sure that the class option is selected there. And then I'm going to come down here and type in wine.cs. And I'm going to add that. Visual C# Express has made a new wine class for me. Let's go back over to the snippets. And let's just copy this class in its entirety over. Copy this into the wine class. And save that. So now we have our wine class defined. Let's go back over to the program and let's copy in some other code from the snippets, which is right here. First, let's just copy these few lines and we can explain what's going on. Let's take a look at the wine class to see what we've done before we go any further. Here is my custom-built object. It's a class that encapsulates the notion of a wine bottle. And you can see I've got several private members here. And because they're private, code that is not inside this class can't see them. So I have a name, I have a year, I have an appellation, which in the wine world is where the wine comes from. I have a wholesale price, and then I have a retail markup of 1.35. So I've got a 35% markup on whatever wine I buy. Then I've got a property called price. And you can see that the price is being calculated on the fly by multiplying whatever the wholesale price is times the retail markup. And in the setter case, I'm setting the wholesale price to the value. So I'm not actually setting an internal price variable. I'm just setting the wholesale price, which will be then calculated by the retail markup. I also have a property, which is a string called the menu description. And if you've ever been in a restaurant, you've probably seen this. Wines are usually described on wine lists as having the year followed by the name and sometimes where they come from. So I've got a string property that's being built up on the fly right here from the private internal properties that I have. And then I have my public constructor. And the constructor is what creates a new instance of the wine object. And it's just taking a bunch of arguments and setting them into the private internal member variables. So let's go back over to the program. And you can see here that I'm instantiating a couple of instances of the wine class. I've got a year for each one. I've got a name, and then I've got a string that explains what the origin is. And then I have a wholesale price, which is going to be used to calculate the retail price. So let's go back over to the snippets. Let's do some exercising here. We're going to write out some of these property values. I'm going to just copy these lines of code right here. And go back over and paste them in. In the first case, I'm going to write out the menu description and the price of the two wines. So I've got wine 1 and wine 2, And remember, back in the wine class, each one of these properties is being built on the fly. So I'm going to save, I'm going to build, and I'm going to run this. And you can see that I've got wine 1 is a 2003 Chateau Saint Michel Merlot from Seven Hills, and it's $31.72. And then I've got a Mark Ryan Dissident, that's from Ciel du Cheval, and that's $54. But remember, those aren't the numbers that I put into the constructor. If you look at the constructor, I've got 23, 50, and 40. The reason why those numbers are coming back differently is because, let's go back over to the wine class, is because of this logic right here on line 20. On line 20, I'm taking the retail markup and multiplying it by the wholesale price. But from the point of view of the code's consumer, let's go back to the program, you can see all I'm doing is accessing this price property. I don't have any knowledge of how that's being generated behind the scenes. Let's go ahead and change the wholesale price of one of the wines using the setter, and then we'll write out the new price. Paste that in here. What we're doing now is using the setter logic of the price property. Here I'm changing the wholesale price of wine 2 to $45. And then I'm going to write out the wine description, and notice how the retail price has automatically changed because of that calculation logic. So I'm going to just run this. And you can see that in the first case, it's $54, but because of the price that I set here in the setter, the new retail price is being calculated as $60.75. Okay, let's go back to the code. The reason why you use properties is because you want to encapsulate some logic inside your class, give it the appearance of a member variable, but it has logic behind it that determines how that property is calculated on the fly. And you can use this technique to expose private internal data in your class in a controlled fashion. And you can get really creative with this. Suppose, for example, I wanted to log every time somebody changed the wholesale price of a wine. Well, here in the setter logic, I could just simply add some code that would write out to a log file when the price was changed. Or let's suppose I wanted to use my debugger to set a breakpoint on whenever a value of the property was changed. And you can't do that on a private internal variable, but you can do it on a property. So properties are really versatile, and they make your code a lot easier to encapsulate and expose and make consumers use their classes in the way that you feel best they should be used.